So we left off with our previous video of doing a surfacing or facing cut with a traditional high-speed steel end mill, 3/8 inch in size, on our 1/2 inch workpiece. Now we're going to take a look at a couple of different cutters, and the first one we're going to use is this carbide insert fly cutter. This tool is kind of a little bit of a hybrid. Sherline sells it as a fly cutter, but it also very much resembles a single fluted mill, because this allows us to do a 90-degree cut on the side of the cutter, which a lot of fly cutters typically don't allow that. So we're going to go ahead and use this cutter and do a pass here. Afterwards, we're going to take a look at a more traditional style fly cutter and see how that varies. So this tool is fairly simple to insert. It just has a number 1 Morris taper, so 1 MT. We just insert it into the spindle, and then through the top we drop a drawbar of the correct size, and then we snug it in there. We don't need to be super tight, but we do want to draw it up into the taper. So we're going to bring our cutter down. We've got it roughly center line on the part. We can shift it front or back, either way, it doesn't really matter too much. The approximate diameter of this is about 1 inch, a little bit over. I didn't get a real precise measurement there because the carbide overhangs. So this is going to allow us to surface this piece in one pass, since we're only 1/2 inch wide. Now make sure you lock the Z-axis again for the best finish. Remember your safety glasses, and we're going to turn the machine on. Now we have a few different considerations here regarding our speeds and feeds. To begin, we've reduced the number of cutting points from 2 to 1. We had a 2 flute cutter, now we basically have a 1 flute cutter. However, we've also increased the diameter of the cutter, so those are probably going to cancel each other out. We'll get into specifics on speeds and feeds later and what the math is, so you can calculate exact numbers if you so wish. But again, normally just start out nice and slow. So take your time, we're not really in a rush. It's going to be a very, very fine cut at first, since this is the first time we've used the tool. Our first pass on the piece. Make sure the piece is level. Now we're getting cutting on both the leading and the trailing edge of the cutter, because our tilt is a little bit off, or it could just be simply a little bit of flex, or it could also be just more of a polishing cut that's taking the arcs that we mentioned before off of the piece. So I'm going to come down 5 thousandths, take another pass. And we're going to increase the speed as well, so that we can increase our feed rate. And we can keep taking passes along those lines back and forth until we get to our desired thickness of the piece or height of the piece, which is non-critical in our application, but we're going to target around 3/4 of an inch. So there's our surface cut. You can see that it's a little bit more uniform versus what we were getting with the 2 passes. But eventually you're going to get to pieces that are too wide to make in a single pass, regardless, if you're going to be doing anything a little bit larger on the Sherline. But in a lot of cases you may want this appearance of a single pass. Now this is a little bit of a rougher finish, it isn't quite as fine a finish, just again because the way we were doing our speeds and feeds there. The first pass we took was actually quite fine, because we had a very minimal cut, and we were feeding at a much slower rate. I'm just going to come in here with a small ruler, and this piece I did cut extra thick so we could be doing a lot of these passes and not get too small on the workpiece. So we're still at 7/8 of an inch, so we still have to take 1/8 of an inch off this piece, so we still have quite a bit to remove. So with that in mind, let's try taking a 10 thousandths cut. Always make sure we can clear. Now the larger diameter cutters are also going to throw chips further, particularly at the higher RPMs we run them. So be aware of that. The mill can make a much bigger mess than what we've done on the lathe. So here's 10 thousandths. If you're doing this in your living room or dining room, you may want to really consider a chip shield of one sort or another. And we'll get into those type of accessories also as we go along. Now, one thing that can help here is I've got kind of an enclosure around the back and the sides, but in the direction that I'm cutting right now, a lot of these chips are coming straight off the front. When we cut in the opposite direction, those chips will head primarily towards the back and not necessarily cover us as much in small chips. Now, we're dealing with aluminum and we're dealing with relatively slow speeds, but as we start to get into more advanced machining, we're going to get to the point where those chips coming off of there can be quite hot. Particularly once we get into using a CNC and using higher feed rates and using those carbide cutters, a lot of the friction and the heat gets sunk into the chip that's coming off of the piece. So be aware of that. They can burn you. They can also melt your clothes in extreme cases. So a lot of times you'll see machinists and welders and such will only wear cotton or wool, other natural fibers, because they don't melt. Whereas nylon and polyester and some of those other synthetics will actually melt. Now, in the types and the size of machining we're doing, it's not a huge safety concern as it would be, say, with welding. We're not going to melt our clothes to our body and cause severe burns, but don't wear your nicest shirt when you're doing this. So this is a 15th cut, 15 thousandths. Handling it no problem. Now, when you're first getting started, it's a good idea to shut the machine off anytime you're going to be reaching around it, so or over it, so that you don't get anything caught. Adjusting our X and Y axes, we're going to be commonly doing with the machine running, but since I'm reaching around to the back and I'm releasing the Z-axis lead screw lock and then setting an adjustment, and we're going to jump to 25 thousandths, we're going to skip 20, it's a good idea to turn the machine off. Because I'm doing a little bit of a heavier cut, I am taking a slower feed rate. I can go a lot faster than this. I mean, we're not pushing the machine in any way, shape, or form right now with this cutter and with this cut. But just take it slow. See what feels good to you. See what turns out the finish that you want. At this point, we're doing roughing cuts. And with a roughing cut, we do plan on doing a thinner finishing cut at some point before we complete the piece. Now, I said we needed to take 1/8 of an inch off, which is 0.125, and I don't think we've even done half of that yet. Now, when you're doing this yourself, take small increases, so maybe 5 thousandths at a time. Some cases I'm jumping 10, 15 thousandths, but you'll want to take it a little bit slower and also just get the practice. But in order to make sure the video isn't an hour long, I'm going to skip some of those interim cuts. So in this case, I'm doing a 40 thousandths cut. And at the lower RPM, I was getting quite a bit of machine vibration. So I've increased the RPM a little bit. And I'm keeping a nice slow feed speed on here. Now again, I'm gonna take a fairly rapid cut now. Until you're comfortable with the machine and know what its limitations are, I wouldn't recommend this. This is probably going to get fairly noisy. So there we're shaking quite a bit. I was taking a faster cut. we're taking a dry cut, we're using a single edge tool, but the machine handled it. I mean, the workpiece, the finish is still fine, particularly for a roughing finish. I believe Shoreline recommends no more than about a 50,000th of a cut on most materials. And at 1/8 of an inch, that would be 1.5 passes for us to get down to the size we want. So at this point, we've only got about another 32nd of an inch to remove. Again, the dimensions of this piece aren't super critical. We could take it out and it'd be fine now. Now, a 32nd is a little bit over 31 thousandths. We're just going to take half of that at about 15 thousandths. And then we'll do a last finishing cut at just 5 or 10 thousandths. Again, we're not trying to get super precise here. This is actually within what would be acceptable tolerances for this type of part. But it's good practice. Now just measuring with the ruler there. Obviously, if we were trying to go to higher tolerances, we'd want to use a caliper. Now sometimes our dial calipers and digital calipers are going to have a hard time getting into that space, which is where the spring calipers and friction calipers can come into play to help us transfer that measurement. And then we're really going to want, if we were really going precise, we would then measure with a micrometer. But we're just making a simple, fairly rough piece. So we're not going to worry about that. Now some of you might be asking, how would one of these chips burn through my clothing? And where it most often happens, or most easily happens, is inside your pocket. So a lot of these chips are going to hit you, bounce right off, so they're not going to do any harm. The ones that can cause you fun burns are the ones that drop into your pocket and then sit there cooling for a few minutes. And as they cool, that's where they can melt through your shirt. So this is just a 10 thousandths pass. Taking it slow to get a nice finish. We are going to turn this into an actual working piece, and these finishes that we're putting on it are going to get beat up as a clamping tool, things along those lines. So you really don't need to worry about this finish being fine. But again, this is just practice for you. So if you want to, take the time, try to get some different finishes on there and see different smoothnesses and how much reflectivity you can get, things along those lines. So we've done these two sides as the piece sits right now, our front and back. Now we still need to do our top and our bottom. The order of operations that we're doing this in right now isn't necessarily the order you would do if you're trying to make a highly precise piece. But once more, we're not making that highly precise piece. We're making a fairly rough piece, so we can cut it in whatever order is convenient and more efficient for us rather than going for precision. We do, however, still want to deburr. Just always deburr. So as we get ready to do this other face, we see that we're going to drop into the jaws. The parallels we have in there are not tall enough, so we'll take those out, give it a decent brushing, and then I'm going to go up 2 sizes in parallels, which that looks like it's going to work for me. So again, try to make sure that when you're closing the vise that you're doing it in a manner that's going to actually clamp the workpiece. So we're going to bring our tool over to the piece so we can set our initial height. Now I'm being overly careful here. I'm taking a very, very thin, light pass. We're probably not even going to see it cut the entire surface. We might see it cut an edge over here and an edge over here. But just take it slow. You don't need to be in a rush when you're first learning this stuff. And the purpose of this cut is just to get a decent finish. So we are going to try to take a light cut, slow feed speed. We are taking enough of a cut, and this particular bar was flat enough that it appears we're going to get a complete cut. Sometime on these extruded pieces of aluminum, they can be not entirely flat. So, and that's all we really need to do on that face, is we've squared it up and cleaned it up to where it's nice and smooth compared to the factory finish although this bar really isn't that bad, but you can see some marks and dents. If this was a showpiece, then you definitely want to pay attention and do this type of thing. We are going to be beating these up though, so you really don't need to take this time other than for your own practice. Now we'll deburr again, because we did create a little bit of a burr on that edge. And then we'll face this one, but we're not going to use the same cutter. Okay, so I don't know if I had a camera malfunction or an operator error, but I did miss the recording of using the fly cutter. It operates in the exact same way as the other one. We just have a larger swing, and we can get a really nice mirrored polished finish on these. Again, I wasn't going necessarily slow or running it at a high enough speed to get the perfect finish on it, but we do get a pretty nice finish fairly easily with the fly cutter. So with the fly cutter, there are a couple of safety concerns that we've got. You want to make sure that these screws are tightened down in there very, very securely. You don't want to have this extended all the way out all the time. Just extend it out far enough in order to cut the piece that you're working on. Since we're working on a 3/4 inch piece, I've got it pretty much all the way in because we can get about a 1.5 inch swing right now as it's set. This is one of the more dangerous tools in the shop because as it turns on, we can see that the cutter blurs out, particularly at higher speeds, so we don't necessarily know directly where that piece is sitting at. Also, if these were to come loose, this isn't captive, so it'll just come flying right out. So that's another safety concern with these. As long as you follow the precautions, check to make sure these are tight, keep your fingers and hands well away, and any clothing and hair and all that good stuff well away from the cutter, you'll still be able to use it safely. It does take a little bit of time to get used to it. They can be a little scary at first, particularly when they're swinging out wide. Although on the Sureline, we're dealing with a fairly small fly cutter still, so it's not as daunting or as scary as it could be. And I wanted to compare that over here to our previous cutter, which was the insert cutter. You also want to make sure this screw is tight. However, the carbide insert is captive, so even if that loosens a little bit, it's not going to go flying. Mine was a little loose from the factory. This style of fly cutter is more traditional. This would typically be considered a single flute end mill because it can cut a 90-degree edge, whereas on a fly cutter, you're really only going to be doing surfacing cuts. You're not going to be doing any rabbiting or anything like that with it. Now, if you have this style of cutter, but you want to have a carbide insert so that you don't have to sharpen up that brazed insert, you can just replace it, things along those lines. The tool did come with this brazed insert. This is an A-style left-hand cutter. So if we wanted to, we could get a 1/4 inch A-style left-hand carbide insert cutter and pop it in there, and then we'd have kind of the best of both worlds. Just another view showing you this is a 1/4 inch AL. And this style of fly cutter is going to allow you to cut a much larger arc. That's going to be dependent on how long the bar is on your cutter. Since we are getting further out, we do want to reduce the speed because our tip speed, the further out it gets, the faster that tip's going to be moving relative to our RPMs. And now we have surfaced all 4 long faces of the piece. We just have these 2 short ends to do. Last thing I want to discuss is how to remove these cutters from the machine. So these tapered cutters, I've loosened the screw up top and given it a couple of turns, but the cutter is still very, very securely in there. It's not coming out. This is where our trusty little hammer comes back into play. We want to make sure that we're holding the bottom of this cutter. We are still threaded on, but just for safety, keep a hold on it. And then we're going to take our hammer up to the top of the drawbar screw and give it a couple of taps. And that will allow it to now be loose in the spindle. Now, always tapping like that, and particularly if you over tighten the cutter, you can get it stuck in there pretty good. But always tapping and hitting on it can knock your machine alignment out, which is one of the reasons we want to check our alignment. And we'll also look at some other fixtures and little devices and tips and tricks to allow us to remove those cutters without that pounding action.